Alright guys, welcome back. Like I told you, it is later in the day on the 23rd. I don't expect that you guys will be seeing this till the 24th or at some point later in the week. But I want to get this video up so you guys can keep moving forward. So first and foremost, finish your Chapter 6 Mastery. If you have not finished that yet, and I'll show it here real quick, and you could go ahead and, if you lost it, you could even just use the video to try again. The solutions for number 1 are already written here, but for the rest of them, first thing I'm going to do with this video is very quickly go through all the answers to this, but this was the document. It was the one that told you to pretty much put everything on graph paper. We took it, seems like a long time ago, but it was only about 11 days ago that we were working on this in class. So this was the mastery. Please make sure you have it done if you are going to continue watching this video and get the solutions. The solution for 7 is also written on the test. But then there's the rest of the test, so if you needed it, if you lost it or something, there it was. But really quickly, I'm going to go over the answers for this, and then I'm going to go over the actual solutions. If you got any of the answers wrong as I check them, please mark your test that you will want to go back and review and check what you did. If you then had any mistakes, I want you to try to figure it out on your own. Don't just get discouraged and say, well, I guess I don't know how to do that and I need Hudson to show me. That's the wrong idea. Get motivated, get determined, figure out what you did wrong, and then to verify that you did it the right way, or if something is still kind of stumping you, if you're still in that trap door, go ahead and go back and finish the video, and I will show the rest of the solutions. So right now, if you are not done with the mastery, you should not be watching the video. For those of you who are done with the mastery, on 1, when we simplify and group together zeros, I kind of showed this in a few different ways here, but my first mat gets left with just 2x and a -1 because the -1 does not cancel out with anything else. The second mat here, that negative and that positive can go together, that negative and that positive, x's can go together, that negative and that positive, went ahead and circled those, they can go together. So we have 2 positive x's left, because remember these went together and made a 0. And then we have these 3 negatives left, so this is 2x and a -3. And then mat C here, the x squareds both canceled out, a set of positive and negative x's canceled out. We got left with 2 x's and a +1. So hopefully you were able to identify and make all those zeros. Again, just expression mats, not equation mats. We're not trying to solve for what is x. We were just trying to put together like terms and remember how we make zeros. For number 2, and now I'm going to speed up because we're going to just talk about answers and then we'll go back and do all the solutions. Number 2, a boundary point. You need to say something to the idea that a boundary point separates what x can be and cannot be. And I will show the example of what you should have had drawn there in a minute when we go over the solutions. But the boundary point kind of starts or stops what x or your variable's allowed to be. For 3, the answer you end up getting is x is greater than or equal to 15, and you should have that graphed hopefully accurately. For 4, you end up with, on part A is less than or equal to 4, B is m greater than 2, and C is x is less than or equal to 1. In 5, we're going to solve these equations. So 5w comes out to be a half, or 0.5. In B down here, B comes out to t of a value of 3/4, or 0.75 if you're one of our calculator users. And in part C, we get that k is a third, or 0.3 repeating. So fractional answers there for B and C. For 6, we get that x is 17, and we can check that, and we'll show you how we know that's for sure when we go through the solution side of things. In 7, I think a lot of you pretty quickly were able to see that if that's a -4, we should not have subtracted 4, we should have added 4. And we'll go over how that properly solves out and gets the solution of x equal to 1. In 8, all you need to do is show that x does equal 8. That is correct. So it just says show the check process. All right, so either you wanted to show plugging that back in, which we call substitution, to back up x is 8, or you could resolve this and figure out what you get for x on your own. Here with Kyle and Mike arguing with each other, those are 2 of my friends from college, both of them are right. Surprisingly, both Kyle and Mike are correct. You can either start by dividing or you can start by distributing. I will show that again when we go over the solutions. But for 9, x comes out to be 5, by the way. So when they solve that, x comes out to be 5. In 10, more equations to solve, but these are kind of a trickier situation because they all can't be solved. 10a can be solved. It is x equals 6. 10b, we get to a solution of the left side and right side are identical, so it's all real numbers. And then c is a no solution situation, and we will go over why c is a no solution situation in a minute. 11 is 40 minutes, and that is a tough problem, but 11 is 40 minutes to get down to the 76 degrees that you're looking for. 12, Severus has 95 points on that exam, and Lily has 110. Again, points are silly. You guys all know that I prefer mastery-based grading. In 13, George comes out to be 12, Mary Lou comes out to be 24, and Kate is 10 years old. And in 14, when we either use the 5D process or do a little bit with powers and exponents, we could actually solve that way as well. We get that the height is 6 and the base is 12. So if you had any questions wrong, please stop the video and go back over everything. I'm going to show the solutions all written out here real quick. So right now would be that moment. It's your final chance to be honest and stop the video. If you need to do any of this on your own, it's your practice. Don't cheat yourself out of it. So number 1 was on the test. We talked about how those grouped together and created zeros and simplified then. Number 2, and I shaded this in 2 different colors to show 2 different things. If x was just greater than the number that we're talking about, that number would be your boundary point, and we would only shade off of the boundary point. The inside of it would not be shaded. But when we have the or equal to bar, the inside of it does get shaded. So that's why I showed that with the pink Sharpie there. What I've kind of told you guys through class and told students for a while is if this has more ink to write, then this is going to have more ink to shade the values. And then the only number that we said we have to necessarily have is the number of the boundary point. It's kind of that split point, right? So if this was like 17, then this would be 17. Down here in 3, x is multiplied by 3 and it's being subtracted by 2, so we undo that subtraction first by adding 2, or we're really making zeros there. We get 3x is greater than or equal to 45. We divide by 3 on both sides and get x is greater than or equal to 15. I don't know why I chose to be showing these things in red and this in orange, but as I was asking myself, why am I showing division in orange, got me thinking about how I've been snacking on cuties lately, and it's easy when you have like an orange or a clementine or whatever they are, they divide into pieces really well. So I'm just, for this whole test, pretty much going to be showing division in orange. In 4A, let's scooch this paper up a little bit. So 4A is right here. A was being subtracted by 3 and was less than or equal to 1. So of course we use that same algebraic solving. We add 3 on both sides, getting 4 on the right side. Inequality symbol stays facing the same direction. It is less than or equal to, so the or equal to shades in our point at 4 and the less than shades to the left. Either your shading should go all the way to the arrow at the end of the line or put your own arrow on the end of your shading. Same story for part B. We subtract 1 from both sides to get rid of that plus 1. We then have 2m is greater than 4. We divide by 2 on both sides, and we get m is greater than 2. And we shade to the right, leaving that point at 2 open because m is just greater than 2. M is not allowed to be 2. It's allowed to be anything greater than 2. And we could plug in values to check this and make sure that we have that solution correct. Then in 4, part C, you always want to make sure that you have these things copied down correctly, especially when there's like 4 parts to deal with. So 3x is positive, that 1 is negative, that x is negative, and that is a positive 3. So I'm going to go ahead and scooch this paper up so you guys can see my whole solution. The dangerous thing right here, there's a bunch of options. There's a lot of stuff going on. There's x's on both sides. There's constants on both sides. So think about what is the easier option for you, which is not necessarily what's easy for me, but for me, I don't like negative variables, right? I've talked about this in class. Negative variables just kind of make me uncomfortable. When we're doing division with negative variable values, things get really complicated. We have to flip around that inequality symbol if our variable amount is negative. There's just a whole lot of stuff that happens. So instead of dealing with all that, I just get rid of the negative variable amount by adding an x. So those make 0. Over here it makes 4x. We still have the negative 1 on this side, which I rewrote the subtraction as addition of the negative. We've talked about how we're allowed to do that. My symbol just falls down, less than or equal to still. My right side is only 3 now because the x's canceled out over here. I add 1 to deal with that negative 1. These make a 0. Over here, that's going to make 4. Then 4x is less than or equal to 4 to get x by itself, or just 1x. Remember, we don't have to write the 1, but this comes out to just be 1x. So to get to just 1x, you want to divide by 4. And when we divide by 4, we get 1x is less than or equal to the value of 1. So we put 1 as our boundary point. We shade the less than, and we shade the or equal to. Moving on to 5. Again, check that you copied it down correctly. 6w plus 38 equals 41. All right. So first thing we do, get rid of the plus 38 by subtracting 38 on both sides. We have 6w equals 3. We divide by 6 on both sides, and we see that w can be written as 3/6, simplified to the fraction of 1/2, or the decimal value of 0.5. To check that, which 5 asked you to show the check process, we're going to substitute the value that we have for w. Any of these would work, but the 1/2 in my mind is the simplest thing to plug in. So we substitute that anywhere that we did have the variable. So the only place that we had the variable was multiplied by the w. So we have 6 times the half plus 38. What is 6 times a half? Well, it's 3. So 3 plus 38 is 41. And since 41 is 41, that's a good thing. We like that. Over here for part B, same sort of thing with inverse operations. We want to get rid of this addition of 8. Now again, just to pause for a moment and talk about, well, why don't we divide first? Remember, we could divide first. Technically, we say that we can, but if I divided by 4 here, everything would divide by 4. That wouldn't be that bad with the 8, but this 11 over here, to divide 11 by 4 would be just really, really kind of nasty and gross, and we don't want to deal with that. We'd either have an improper fraction or a decimal, and none of that is really fun, so we just subtract first. It's your option, but you're thinking about which one is the easier option. So we subtract by 8 on both sides. We get 4t is equal to 3. We know that because 4 is being multiplied by t, we need to divide on both sides. Oh, I forgot to write my division in orange there. But we get 3 divided by 4 as our answer, which is the common fraction 3/4, or the decimal 0.75 or 75 hundredths. We can check this by plugging in or substituting that fraction in where the variable was. So we had 4t. Now we have 4 times 3/4. And remember, any number can be made into a fraction by just putting it over 1. We'll get into irrational number. Okay, almost any number. I'll go ahead and correct myself for the nitpickers out there. So 4 times 3/4 comes out to be 3. And we can figure this out. We can double check that if we want by saying, well, 4 times 3 in the numerator would be 12. And 12 divided by 4, which would end up in the denominator, is 3. Or you can think about the process of cross-canceling or cross-reducing, that a 4 on top and a 4 on bottom will cross-reduce out to a 1, leaving us just with that 3. And 3 plus 8, does that equal 11? Yes, and we like that. Moving on to 5, part C, which was a little bit tougher here. It had a -4, so you can't really see that. Had a -4 and a -7, and then a 9k, just a lot to be careful with. So when we write it down, we double check, okay, -4, -7. First thing I do is I rewrite that, right? My -4, I just put it in parentheses to kind of group it nicely. For my -7, I'm putting that in parentheses because over here, there's a lot going on. That's just going to make it a lot easier for me to realize, oh, I should add 7 because this is -7, and that will make 0. So when I add 7 over here, be careful. These are good guys versus bad guys. So we've got good 7 versus bad 4. The good is going to win by 3. And then we have 9 times k equals that 3. We do that division to do the inverse operation of the multiplication. 9 divided by 9 will give me just 1k. And 3/9, now we're kind of going right to left. Sorry, 3/9 can reduce down to 1/3, which we know 1/3 is the repeating decimal of 0.3. So we don't really like the repeating decimal. I mean, that's an accurate way to write it. Remember, we like the fraction better, especially when we go to check. When we go to do our check process, putting in a 0.3 repeating here would be, first off, really annoying because I'd have to deal with that in the calculator. And it's not 100% accurate if you just type in like 0.33333 and you only have like a few of them. That's not actually accurate. So the fraction 1/3 is way better there. What's a third of 9? Well, it is 3. What's 3 plus a -7? It is -4. And because these match, we're happy. It's all good. We move on knowing that our answer is correct. So in 6, we talked about, we'll look at how we know that x is 17. So we had this image to start 6, right? And it said kind of what's the value of x. If we first start by just cutting our situation right there, so I'm folding some paper here, that can be written as 2x plus 6 equals 40, or we never really even have to think about that plus 6. We could immediately take it off both sides and say, well, what's left over? If I took 6 off of here, well, this span then is left with 34. So really what we're going to work with here is that 2x is equal to 34, so we divide by 2 on both sides, and we see each x is 17. We can check that by saying, well, okay, so 17 plus 6, and if I write that out, although addition is supposed to happen left to right, I could group things, right? We could apply the associative property here, and we could add that grouping symbol. And 17 plus 6, I kind of like that makes a 23, because then my 7 and my 3 work together, my 20 and my 10. So this all comes together to be 40, and that checks our solution and verifies that, yes, in fact, our x value here would be 17. Moving on to number 7. I was about to say if I'm moving too fast, tell me, but if I'm moving too fast, you can slow me down on YouTube. On 7, we start with this, and like we already identified, there is a mistake in this solution. That subtraction of 4 should not have been subtraction. It should have been addition. So when we go to do this, I actually don't even do that first. Because remember, when we have options, you get to think about what's the easiest thing to do. And like I said earlier, negative variable values, I just really don't like negative variable values. So to get rid of this negative 2x, I'm going to add 2x. And when we do it on both sides, my left side, this becomes 0, and my 6 just drops down. My 8x plus my 2x equals 10x. With my -4, that's still over here, because the only thing I did over here was mess with the variable value. Now, because on what I've kind of made my variable side, I still have this -4, so we get rid of that by adding 4, and do it on both sides of the equals. We get 10x is equal to 10, and when we divide on both sides, we find out that x is actually just 1. So all of this complicated stuff to tell us that x is just 1. Now in 8, this is where we have to check, is Chelsea's solution actually correct? So I'm going to fold my paper again. So to check that, we substitute in. So where we had x originally, we sub in the 8. Do 6 times 8 is 48. And then we add 2 to that. It is 50. So we verify that x is 8. With Mike and Kyle arguing for number 9, I showed out both solutions here. So different route, but same destination, right? This route, we divide by 4 on both sides. And remember, this is dividing the entire left side, but it only really happens right here because that would have been multiplied by 4. If you want to see some justification of that, come over to the pink side and divide by 4, divide by 4. What we would get is x minus 2. So if I divide it by 4 first, I get x minus 2 equals 3, and then we add 2 to both sides and we get x is 5. If I take the route of distributing first, this is the trap door because this minus 2 is really like a -2. So that becomes 4x plus a -8. To get rid of the -8, we add on both sides. And to get rid of the multiplication by 4, we divide by 4. Same answer. 2 different routes. One was maybe more scenic. I don't know. They both kind of took the same amount of time, really, because step 1, step 2. Step 1, I guess, is distribution. Step 2, step 3. So technically this way is better, but it's all whichever you like. All right, moving on from 9. Number 10, we had some more equations to solve. Like we said, they are not as easy there. So you always want to double check, did I copy these things down correctly? Yes, yes. And then it all comes down to, did I make any math mistakes? I had to write a little bit small over here. So we'll just go one equation at a time. So in A, we had the x multiplied by 4 and then being subtracted by 6. So we're going to undo that subtraction first. We could think about, could I divide by 4? But nah, the 6 and the 18, neither of them really work very nicely. So we add 6 first, then we divide by 4, and we get x is equal to 6. That's perfectly fine. We have one answer for x. In part B, this is where things get a little tricky. There's trapdoors here. 2 would distribute if I take the pink Sharpie route, and I'm going to talk through that first, then we'll come back and look at the orange. So if I distribute first, I'm going to have 2x and a negative 6, because remember, negative 3 or minus 3 doubled gets that negative 6, and the right side is also 2x and a negative 6, because ignore that orange. So what that tells me is my left side and my right side are identical to each other. From here, we could add 6 to both sides, and we would then get 2x is equal to 2x, and then we could divide both sides by 2, and we'd get x is equal to x. But what should happen in your head is an alarm goes off and you say, oh, if my left side is exactly identical to my right side, they're identical and x doesn't matter. So our answer is all real numbers. Sorry, hopefully my focus comes back here in a second. I'm really hoping my video comes back. Alright, but I'm going to start talking through C while that tries to figure itself out. Alright, as we all anticipated, we're going to have some issues as we work through tech at home between my dog whining out in the hallway, and I think because I'm running out of daylight, our focus was starting to get a little goofed up. So hopefully this is a little bit better now. I grabbed a lamp, hopefully gives more light. So in B, we were just discussing the pink got us to the same exact thing on both sides. But if I go back and I take the orange route, and I divide by 2 on both sides, remember that division by 2 over here is only going to impact that multiplier that was in front and kind of waiting to be distributed. And over here it's going to impact everything. So if we divide by 2 on the right side, the 2x and the 6 get divided by 2. And remember, that's like a negative 6, or you can think of it like minus 6, but up to you. That gives us x minus 3, x minus 3. And again, that alarm should go off in your head. If my left side and my right side are identical to each other, that means that any number can be plugged in for x. It does not matter. So any real number, right? ARN, any real number. In C, and we can maybe come down here a little closer. In C, what we really do is distribute the negative 4 first. And I did not show multiple options with this because there's just kind of, this is the best way to go. It's the least complicated. So if we distribute that negative 4, and actually I will show right here, on the test, it's shown as a minus. But again, we've said it can be a minus, it can be a negative. It's up to you to determine what you call it. It's easier for us when we go to do the math if we write this as plus a negative. So we have 3x plus negative 4, which is being multiplied by the 5, minus x, which again, this is like a negative. If I had space on my paper, I would have changed that to plus negative x. And then 7x and then a 2 over here. So we have 3x. When we distribute this, negative 4 times 5 gives us negative 20. Negative 4 times negative x, be careful, there's a trapdoor. Negative times a negative is a positive 4x. This is the mistake I see most people make on this test, is that 4x ends up being negative by accident, and then you think that you can actually solve this problem. That's not correct. Because if we get 3x and 4x on this side, they combine to 7x, and we still have that negative 20. The right side is 7x and a 2, which can't be true. Because we said if we have this thing over here, right, 7 of those things, and a debt of 20, versus 7 of those things, and a positive 2, that's not the same. These are not equal. So really, this was a lie from the get-go. So we kind of said, these are lies. So that was never actually equal. We could go back and say, well, the left side is not equal to the right side. There's no solution to make these equal. It just can't be true. Now, 11 was kind of a tricky problem to get into its equation format. It says a room reaches 88 degrees Fahrenheit, then somebody turns on the air conditioner, and it's going to lower the temperature in that room by 0.3 of a degree every minute, not a third. I like that some of you wanted to use the fraction form and say 1/3 of a degree, but if somebody could actually tell you that something was changing by 0.3 repeating, especially measured on a thermometer, that'd be very impressive. So here's what we can set up. The room starts at 88 degrees. It's hot. I was tempted to write it in red, but I wanted to keep my formatting, so it is written in blue. The and then I'm going to write as an addition, because and then somebody is doing something else. What are they doing? They're decreasing the temperature by 0.3 or 0.3 of a degree times the number of minutes that that air conditioner's been on. Where do we want to get to? Like, what's our destination? 76 degrees. That's what we're hoping to get to, which right now would be really hot if your house was set to that. It would feel really warm, but during the summer, 76 would feel nice. That would be a decent temperature for your air conditioning. So the first thing we do is subtract this 88 from both sides. Sorry, I got a little sloppy here. It happens. Subtracted 88 over here got me -12. And now do not fret. Having a negative on this side is okay, because we have a negative on this side also. So the -3/10 and then the -12. When we go to do the division to get m by itself, the negative divided by the negative is going to give us a positive answer. So then, when we do that division on both sides, we get 40. And that's something where you would probably need a calculator. The other thing that you could think of, I'm going to ignore the negatives, but if you did 12 big fraction divided by 3/10, remember that's the same as 12 over 1 divided by 3/10, which is the same as 12 over 1 times 10/3, because when I tell people use a calculator, I like to also show, well, you don't necessarily have to. This becomes 120 over 3, and that itself is 40. So you wouldn't have to necessarily have a calculator here to deal with that situation, but especially if you're dealing with both negatives and this decimal form, it's probably just the easier way to go. So Lily and Severus are comparing their exam scores, and you know, guys, no offense, but normally girls just, I don't know, kind of have better test scores. I don't know if they care more or if they truly are smarter. I'll default to either of those answers. But Lily gets a better test score than Severus, right? The problem tells us Lily's score is higher by 15 points. Severus notices that Lily's score is 15 points higher than his. So Lily is Severus plus 15. We could also say L is just S plus 15 if we're going to say that Severus is S. So S is S. Then they tell us the sum of their scores is 205 points. So Severus plus Lily, well, I can replace or substitute Lily with S plus 15. I can then combine like terms, because these are not like terms. My S and my S combined give me 2S plus 15. We subtract both sides to get rid of that plus 15. Gives us just 2S equals 190. We divide by 2, and we get 95. Now what that really tells us is when we plug that in to find Lily's score, is that Lily got 110. So either there are bonus points at play here, or that test just isn't worth 100 points. Maybe it's a 200-point test and they both did really badly. Maybe it was a 100-point test with extra credit. Maybe it was a 120-point test. I don't know. Maybe it was a 110-point test and Lily got a perfect score. But this is why I think point-based grading is silly, because you guys probably all assumed that it was out of 100, and when you got this answer of 95 and then got this answer of 110, you were like, oh no, wait, is that right? Things don't have to be out of 100%. So please pay attention. That problem said points, not percents. So it does not have to be out of 100 if it's just points. Now 13, you do not have to use the 5D process. I didn't use the 5D process, so I'm perfectly fine if you didn't use it. But in 13, here, we'll fold it like this so you can see the problem still. Alright, so we've got Mary Lou, George, and Kate. Mary Lou, we're told, is twice the age of Kate. Mary Lou is twice the age of George. I'm looking at too many things at the same time. Kate is 2 years younger than George. So we're going to say George is G, Mary Lou is 2 times G, and Kate is G minus 2. Now when we put all of those together, sorry, my 6's and my G's look similar. I'm sorry. We get 46 equals 4 times G, because be careful, this is the other trapdoor. 2G, 1 more G, and 1 more G. That's 4 G's in total, not 3, because we see 3 of them here. That's 2G, this is a 1G, and this is a 1G. So we got 4G in total, and then this minus 2. To deal with that minus 2, we add 2 to both sides. 48 equal to 4g. We got to divide on both sides, and we get g is 12. So George must be 12, Mary Lou must be 24, and Kate must be 10. Maybe these are some cousins hanging out at like a family reunion or something. Where are we? Oh, we're on 14. Last question. So the triangle area formula is 1/2 times base times height. You would need that to solve this problem. I had it on the chalkboard. I think I asked you guys to all write it down on day 1. So here's the problem. They tell us that the area is 36 square feet. Down here, way at the bottom of your screen right now. Now, area involves multiplying these pieces, which we talked about in class. Gets dangerous because we end up with something squared. We'll talk about that in a moment. But if we ignore that, and we just try to solve it using the 5D process, we know that the base is twice the height. So really, when I pick an h, when I test something for the height and then I plug it in, I know the base will be double that. When I go to do the equation, 1/2 times base times height, this number will always be double my first number. And then we check what does it come out to equal, because I'm shooting for 36. When I try 4, it's too low, and it's too low by a lot. So I decide, instead of just bumping up to 5, I'm going to bump up to 6. Double 6 is 12. What is 1/2 times 6? That's 3 times 12 is 36, and that works out to be the correct answer. So our height must be 6, and our base must be 12. Now here's that alternative option, though. If we set up my equation, like my formula, and then plug in that the base is twice the height, well, 1/2 of 2 is 1, so these essentially kind of reduce each other out to 1. And h times h is h squared, right? A number times itself is that squared. So the only option that we have to deal with that being squared is the square root function, which we are still learning how to do. Remember, the square root function asks what number, when multiplied by itself, equals that number. So when we think about like 4 times 4, 5 times 5, 6 times 6, 6 times 6 equals 36. So when 6 is squared, it is 36. The inverse operation is square root. When we break it apart, we say, what's the square root of 36? It's 6, because 6 times 6 is 36. We'll do more with that in 8th grade math. You do not have to understand square roots quite yet. But then if we know that h is 6, the problem told us the base is twice that much, and the base would be 12. Alright guys, so that is pretty much all I have for you today. And really it's all I have for you tomorrow, realistically, because I'm filming this on Monday. Like I said earlier, just try to stay busy, keep at things, take on some hobbies, say a lot of please and thank you. That was some really good advice that I think I heard from in one of our governor's addresses, is it's really hard to be mad at each other when people are saying please and thank you to each other. So use those kind words. And as always, reach out to me if you need anything. Call, text, Schoology, comment, email, whatever. We're here. We're available for you guys. Maybe not immediately, but, you know, we love you guys. We miss you. But on top of all that, we got to keep doing math. So I will be back tomorrow with more stuff for you. Until then, do the Khan Academy work. There are some quizzes and a unit test up there for you that are due this Friday. Please try to get to those at your earliest convenience, and we'll keep moving forward. Have a great day, guys. Bye.